Hello and welcome to this lecture. This is going to be a continuation lecture for Scilab. In the last discussion, we were talking about fitting using Scilab. These are all the commands for fitting. Okay. So, what are these commands for fitting? Define the value of x, define the value of y, define a fitting function. That fitting function will have, this is a linear least square fit. So, I will have y is equal to m x plus c, that is my straight line. So, in my case p 1 x plus p 2, then exactly copy these commands as they are. Okay. Then finally, execute the data fit is the fitting function, then plot this on the screen. So, this is what you have to do for fitting a straight line through a set of data points. Instead of a straight line, suppose I want a quadratic function, p 1 x square plus p 2 x plus p 3. So, I can give I can give a different fitting function there, a quadratic, then define all the values of p 1, p 2, p 3 and execute all this in the same way. Okay. So, that is how you will do. Then before we start our execution, there are two more things I want to comment on. The next one is how do I write variables into a disk? Remember in Fortran, I used open unit equal to 11, open unit equal to 12 and associated those units with some file names. Okay. So, in Scilab there are no units, you directly write a variable into a file. Okay. Say for example, suppose I want to write a particular variable into some file. So, what do I do? That function is fprintmat, fprint, fprintf, capital M A T. So, fprintfmat allows you to write a variable into that file called filename.txt. So, not only you can write one variable, you can write several things into your filename.txt, and as you execute your Scilab program, keep on writing those variables, different variables into this file, and at the end you may want now to read those from that particular file. So, how will you read? So, fprintfmat is more like a write statement. The read statement would be fscanfmat. Okay. So, this is my read statement. So, how suppose I want to read the variable from this file, I will now say variable equal to fscanfmat into bracket this quote filename.txt quote complete bracket complete. So, this is how I will read from this particular file and this is how I will write from the file. So, these are the two commands that allow me to write something into a file and read from a file. So, these are the read and write statements. Okay. Now, fscanmat, okay, you can actually, you may have saved many things in your text file or doc file, you can read it from fscanfmat. Okay. So, the data files could be, it need not be always text, it could have any other extension. Okay. It could have any other extension. So, you can read and write using Scilab. So, let me summarize what all we have done using Scilab. Okay. We did not do everything, we just used some of the operations. One was a set of matrix operations that we did using Scilab. Another one, we solved differential equations, then we solved the roots of equations, we plotted many functions. Okay. We also fitted function, we discussed Scilab programming, rudiments of Scilab programming, and we also discussed storage and execution of programs. So, personally I have really enjoyed this Scilab because whatever took me so much time using Fortran programs, I can do the same thing in less than one day with Scilab programs. Okay. But there are also advantages of knowing all the programming yourself, because many of the functions that Scilab is executing, we do not know the logic, whereas when you do your own Fortran programming, you know the logic of every step. So, enjoy both Scilab programming as well as computing. So, now we will execute some things using Scilab. So, what I will do, so I want to now, there is a Scilab environment, you can see on the screen, there is a Scilab 5.5.2. When I double click on this particular thing, this whole menu appears. So, this is my Scilab environment. So, in this Scilab environment, I want to execute many functions that I already described to you during my course of these lectures. So, let us start with matrix operations. Okay. Let us start with matrix operations. So, I will go to my lecture, whichever commands I had actually used, I shall use identical commands now to execute Scilab. Okay. Okay. So, I take this A equal to this particular matrix. Let me want to take this A. So, I will what I have done, I have just taken it, I have taken the, let me paste it. Okay. So, I have got this here. So, what I have done, I took, it shows at the bottom of the screen, I took this particular matrix A 7, 2, 4 semicolon 1, 2, 4 semicolon 7, 8, 9. So, I took this matrix and I enter. So, when I type A and enter, it prints me the whole matrix, it prints me the whole matrix. So, now let us say I want to calculate the determinant of A. What was the command? DET into bracket A. Okay. So, this gives me the determinant, the answer is minus 64, that is the determinant of A. So, let me also calculate A prime now. What is A prime? A prime was the transpose of A. So, let me say B equal to A prime. So, when I enter, so remember what was my matrix? My matrix was 7, 2, 4, 1, 2, 4, 7, 8, 9. So, the transpose is the transpose of a matrix, the column will be the row 7, 1, 7, 7, 1, 7, 2, 2, 8, 2, 2, 8 and 4, 4, 9. This is 4, 4, 9. So, I got the transpose. So, now I want to inverse this matrix. So, how do I invert the matrix? That was very straightforward. So, let us say C equal to inverse of A. Okay. So, when I do that, so what I got, this set is the set of elements of the inverse of that matrix. So, I got C was the inverse of A. So, what I can do now, how do I know it is really the inverse? The best way would be I multiply C by the matrix A and see whether I get the identity matrix. So, let us say D is equal to C star A. So, I am multiplying C, which is the inverse of A, and I am multiplying by A. So, let us see what I get. Now, see, this is my D. So, D is the product of the matrix and its inverse. So, you will see that what are the elements? 1 minus 5 into 10 minus 7, minus 1 into 10 minus 7, again minus 5 into 10 minus 17, 1, 5 into 10 minus 17, 2 into 10 minus 17, 0, 1. So, this is really an identity matrix, because in a computer 5 times 10 minus 17 is a number where there are 16 zeros followed by that 5. So, this is as good as 0 on my computer. So, it is an extremely small number, all the off diagonal elements are small and the diagonal elements are 1. So, you saw that using Scilab in a matter of seconds I can execute the matrix operation. Then we also want to do the eigenvalues and eigenvectors. Remember, that was the very important command. So, let us do this. I will take this lambda x is equal to b diagonal A. Okay. So, I want to take this command and execute in Scilab. So, all I am doing now, I am taking these commands and executing in Scilab. So, I paste those elements. So, I do not know whether it has gone. So, it did not paste or it has pasted. Okay. So, see the last line here, because I am not able to reduce this screen the way I want. So, I have typed lam, just look at the last line here, lam comma x is equal to b diagonal A. Okay. So, actually I have typed it twice, so I will eliminate it once. Okay. If you do it twice, it will give lot of problems, but it was a comment card anyway. So, what I want to do, my matrix was actually small a. So, instead of capital A, I will replace by small a. Okay. So, my lam comma x, lambda would be my eigenvalues and x would be eigenvectors. Okay. So, I will execute it. So, when I execute, look at what has happened. Lambda are my eigenvalues. So, they are given in the diagonal rows. Okay. First eigenvalue, second eigenvalue, third eigenvalue, this is my eigenvalue, and x is a set of eigenvectors. X is a set of eigenvectors. So, to make sure that, remember how is the diagonal matrix obtained from the original matrix? X inverse A x is my diagonal matrix. So, let us see whether I get the same thing. So, what I will do? I will say W is equal to, I want to say x inverse A x. So, what I will do? Inverse of x. So, this is the inverse matrix, this is the inverse matrix of x. I multiply that by A, then I multiply that by x. So, what I am doing? W is equal to x inverse A into x. So, let us see whether it gives me the identity matrix. Okay. So, lo and behold, okay, I did x inverse A x. So, this is the matrix I got. I just will do. So, this is exactly my diagonal matrix. Why do I say this is my diagonal matrix? Look at these. Look at these values of, okay, I already have it, remember. So, my eigenvalues were 15.5, 3.87 and minus 1.39. So, when I did inverse of x multiplied by A into x, I got 15.52, same as this diagonal value, 3.87 same as this value, and 1.3974895, 1.3974895, exactly the same as the lambda values. Okay. So, we saw that using this simple command lam x is equal to b a diagonal A, I am able to get the eigenvalues and eigenvectors. Okay. So, one thing I must tell you that I am not going to do all the very elementary operations in Scilab that we did, like adding numbers, multiplying numbers. So, we did eigenvalues and eigenvectors. So, what I want to do? I want to do the polynomials. Okay. So, let me do the polynomials first. So, how do I do that? So, look at the bottom of the screen. Okay. So, I will say P is a polynomial, these are the coefficients, is equal to. So, one should be sure whether it is square brackets. So, remember here they are square brackets. So, whenever it is a square brackets, you have to use square brackets. So, square bracket 1 comma 2 comma 1. Okay. So, I will use it. So, what is this my function? I expect this function to be x square plus 2 x plus 1. So, I want to solve this equation. Okay. So, P, these are the coefficients of my polynomial x square plus 2 x plus 1. Now, I want to find the roots into bracket P. Remember, here I gave square brackets 1 comma 2 comma 1, here I give round brackets. So, when I say roots P, so it has given these roots. Remember, when it is x square plus 2 x plus 1, that function is nothing but x plus 1 into x plus 1, and for that function the roots are minus 1 and 1. Okay. These are the roots. So, you see that it very easily gave you the roots. Now, let us do a slightly more interesting problem. So, let us say P equal to, let me take a more complicated polynomial. P is equal to, I will give a long polynomial 3 comma 2. Okay. So, I have taken a large polynomial now, it has many coefficients 2, 3, 4, 5, 6, 7, 8, 9. There are 8 coefficients now. So, when there are 8 coefficients, so I had given some problem here. See what was the mistake? I did not give an equal to sign. So, I just made P 2 3 4. So, what I do? I will go back. So, I should say P equal to all that. So, I have done. So, now it gave me a polynomial with these coefficients. So, since there are 8 coefficients, I will read it like this: 2 x to the 7th power plus 3 x to the 6th power, 4 into x 5, 5 into x 4, 6 into x cube, 7 into x square, 8 into x plus 9. So, this is my polynomial which is a 7th order polynomial. Now, I will get roots into bracket p. So, it should give me 7 roots. So, let us see how it is giving 7 roots. Okay. Now, these are the 7 roots, and you know that whenever I have roots of these polynomials, the root and its complex conjugate appear as pairs. So, the first one is a complex root and the second root is a complex conjugate of the first root. Third one is a complex root, fourth one is a complex conjugate of that root. The fifth and sixth are again complex conjugates of each other, and finally, the seventh roots. So, you will see that I am able to calculate all the roots of equations using this very simple command. Now, I also want to execute, I will also put the Scilab slide. So, suppose I want to just express a polynomial, I want to express this side p is equal to poly into bracket 1 comma 2 comma 3 into x. I want to do this. So, let us see what it gives me. So, p equal to poly into round bracket, then square bracket 1 comma 2 comma 3. Let me use a more involved one, 1 comma 2 comma 3 comma 4 comma 5. Let me give a more complicated function, square bracket complete, comma, and x in quotation and bracket complete. Okay. It is a round bracket. Okay. So, when I type it, so it gave me a fifth order polynomial. Remember, it was 1, 2, 3, 4, 5. So, I have a fifth order polynomial which I have generated in this way. So, this is my polynomial, and this polynomial, these are really the roots. When I give in this form, it takes 1, 2, 3, 4, 5 as roots and then gives the expression of the polynomial. Now, if I want to, let me reverse the problem. How will I reverse the problem? I will say q equal to, okay, q equal to. Now, I will give these as the coefficients. Remember, for the fifth power, my coefficient was 1. For the fourth power, my coefficient was minus 15, and for the third power, it was minus 85, Then for the next one, it was minus 225, then it is minus 274, then it is minus 120. Okay. So, these are my coefficients. Now, I am now feeding the coefficients of the polynomial into q. Okay. So, there is some invalid factor. Remember, I gave a round bracket in place of a square bracket. So, I have to correct that. Okay. So, this you have to be very careful. If you give a wrong, any character that is wrong, it will mess up the whole thing. So, now these are my coefficients. So, whatever I did earlier, I am just giving these as coefficients. Now, I will find roots q. Now, I should recover my 5 roots which I gave. Let us see what it will do. Okay. So, it has given different roots. It did not give me exactly what I started with. Okay. I should have recovered these original 5 roots. Okay. Let us see, 1, 15, 85. These are my coefficients. Maybe I have done something wrong. So, even if you give one coefficient wrong, it will give you wrong results. Okay. 1 minus 15 minus 85. So, this was plus 85. See, in place of plus 85, I have given minus 85. So, I got different results. In place of plus 274, I have given minus. So, I have got these results. Now, let me correct that. Okay. I will go back. So, this was plus 85. So, let me give it 85 as plus, minus 120, that is correct. Okay. Where was fifth power was 1, fourth power was minus 15, third power was plus 85, second power was minus 225, this was plus 274, I should change this sign as well, plus 274 and then minus 120. So, let us execute. So, this is my Q. Okay. Now, so you see when I gave the correct coefficients, I got all my roots 1, 2, 3, 4, 5. So, this really tells me that Scilab is an extremely good software to do many of these things. Now, I will do the next thing I want to do. I want to solve differential equations, plotting and all that, but before I do that, let me use a help command. Let me use a help command, so that it will tell you that because if you know how to use the help command very well, even if you do not know, you will be able to learn from the software itself. So, when I typed help, so it gave me, see on the left side, it gave me a large number of files here. You see there are large number of files. Okay. So, these are, so it tells you lots of details about Scilab, it tells you what is new in Scilab, it tells you other sources. So, what I want to do now, I just want to go to help command and do some good graphics. Okay. So, let us see in graphics, I have a 2D plot, I have a 3D plot. So, let me go to 3D, these are all 3D plots, plotting subroutines. What I want to do, just go to that help command, whatever is there in the Scilab help, I will copy on my screen and plot it. Okay. So, let us say I want to do a contour plot. Okay. This contour plot gives me level curves of a 3D surface. Okay. So, it also tells me all kinds of examples. So, it is giving these examples. Okay. So, to execute this, all I have to do, I have to copy paste the lines in the Scilab directory. So, this is what I will do. I will take this, I will take where did my help go? Okay. So, I will take so several graphs are there, I want to just copy. Okay. So, I instead of what I wanted, I got these particular lines now. So, z is equal to a equal to, and I want to apply this. So, I will do copy this into Scilab. Okay. So, I got the Scilab console, I pasted whatever lines were there in the help command, I pasted. So, let us see what it is doing. So, you see it printed exactly what that help command said. It is plotting some graph like this. Okay. So, I will let us try some other command now. Okay. Let us try some other command. So, I go to the help browser, and okay, I go to the help browser. Okay. So, actually I plotted this particular graph using the, I have plotted this. Now, let us say I want to, these are all for 3 histograms. Okay. Instead of that, let us say I wanted a contour plot, because they are very useful in chemistry. So, let us take these contours, I want to plot these contours. Okay. So, let me, I want, these are 2-dimensional contours, these are like your wave functions for a particle in a 2-dimensional box. These are wave functions in a 2-dimensional box. In fact, you can look at the solutions and give those solutions to plot this particular graph. So, right now I want to do a 3-dimensional plot. So, I just want to copy these lines. Okay. So, I took these lines, I will copy into Scilab environment and execute. So, I have gone to Scilab environment, I have pasted all those commands and now I will execute. Okay. I will execute. You saw that I exactly got the entire 3-dimensional plot that I had seen in that help command. So, you will see that in addition to whatever few statements that we have given, you can also go to the Scilab help directory, okay, Scilab help directory, and you will be able to plot many things. In fact, let me try that help again, so that you will see. Okay. So, I have this help browser. So, let us go to this help browser again. So, let us see what are all the options available. Okay. So, in the Scilab you have differential calculus integration, we have done some of this. You have elementary functions, linear algebra, interpolation, computer aided control system design, okay. Then polynomials, signal processing, Fourier transforms, special functions, random library. I urge you to go to this random library and generate random numbers and see if these random numbers are better than what we generated using our programs. Then you have some package, statistics, sparse matrix, okay. You have some interface optimization and simulation. Curve fitting really is part of this optimization, genetic algorithm, simulated annealing, okay. XML management, some other management, input output functions, we discussed this bit. Then graphics, in graphics you have a very large number of ways to do the graphics. Then annotation, these are histograms, color management, these things are there, okay. So, some more graphics, okay. Then in addition to graphics you have data structures, parameters, Boolean, remember we that plus t and plus percentage t and percentage false we already discussed in our earlier thing. This is the Boolean, you have integer arithmetic, strings, all programming we have done so far is only with numbers. So, you can also manipulate strings and Scilab allows you to do that, okay. Time, there are output functions, okay. These are just some of these functions. So, you have already seen now how many functions are there in Scilab. So, I will conclude this lecture today saying that we have discussed some of the operations using Scilab. So, few more things I want to do. I want to solve a differential equation and a curve fitting, that I will do in the next slide. But by seeing all this, you must be really now convinced that it is an extremely powerful tool to do many things that you want to do. In fact, if I wanted to write myself all the programs that are involved in this Scilab, it will almost be impossible for an individual, because this has been created by a large number of people working together and creating this software. So, use it and enjoy different aspects of Scilab. In the next class, I will consider 2 more applications, then we will go to molecular dynamic simulations. I will conclude my present lecture here. Thank you.